Newton's third law. Who knows Newton's third law?
For every action, there's an equal or opposite reaction.
There we go. Awesome. For every action, there is an equal. We'll say but opposite reaction. So this is a statement. This is one that's probably the most famous of any of the laws. If somebody said they didn't know it, if you just gave them that first part, they'd probably finish it out for you. Well, what we need to do is we need to break this down. Right now, it doesn't mean a whole lot. Let's talk about the action for a second. These actions, right, things like pushes and pulls, what do we call those? Forces. So we can think about action as meaning some sort of force. For every force applied, there's an equal. Now, when we say equal, what we mean is we're talking about equal in magnitude or size, right? So 10 newtons, 10 newtons. So equal in size, but then opposite. Think about a force for a second. We said forces are vector quantities. It means it's not just size, but it's also what? It's magnitude and starts with D.
Displacement.
Diameter.
Direction. There we go. So it's not just an amount or a size, but it's also the direction. So remember, magnitude and size are the same thing. So when we start talking about for every force there's an equal force, but opposite, we're talking about an opposite what? Well, by opposite force, in particular, we're talking about not just the sizes are equal, but in terms of being opposite. If I draw this force, what force would be opposite to that? One going this way, right? Opposite direction. If you were moving that way, a lot of times it wouldn't be pushing. So opposite direction. And then again, another reaction. What do you think that is then? It's another force. So for every action, for every force, there's an equal but opposite. So one of equal size but opposite direction force. So this means that can you have a force by itself? No. Example. What I want you to do is I want you to lightly touch the table. Just put a light force down on the table. Right? Now I want you to push a little harder on the table, bigger force. Did you feel that change in your finger?
Yeah.
Yes. Can you touch this table without you feeling that force back on you? No. Right? You'll never be able to put a force on something without you being able to feel it. Because every time you put a force on something, there's another force that's going to be of the same size, same amount, but opposite direction. So if you're pushing down on the table, which way is the table pushing? Up on you. If you're pushing hard on the table, how's the table pushing on you? Hard. Right? So the size is the same, right? And the direction is the opposite. So that's Newton's third law. Now this has all sorts of applications. Everything that you do basically involves anytime you have forces involved. A good example are rockets. Right? Think about a rocket. What's inside of a rocket? Fuel. What happens to the fuel?
It burns itself.
It burns. And that's when it burns, does it take up more space, less space, or the same amount? It takes up more. It wants to expand. Right? It's like, has anybody ever forgotten and thrown a hairspray can in the fire? Or an aerosol can in the fire? Yeah, what's it do?
Boom.
It explodes, right? Because there's no way for that gas to escape until all of a sudden it just explodes. So on a rocket, if you want to think of it this way, there's just a little opening, right? There's a little opening down here. So as this starts to expand, once it catches fire and starts to expand, then the only place for it to leave is through here. So as it's expanding, right, there's a force from the gas on the rocket, press it up, and then what's the rocket do to the gas? Pushes the gas down. So the gas comes shooting out, and the rocket goes shooting up. Now to see this, what I've got I need the front two tables, if you would, kind of stand up and elbow to the back, about where that third line is.
Jenna.
So look at this.
I know she was here. I thought she was.
What I have in here. What I have in here is just flammable liquid, right? I got the bottle set up so that it's on a glass rod that can slide. I've got a hole here in the back. Right now it's off plugged. So right now this is off filled with flammable fumes. Okay? What I'm going to do is I'm going to uncork this, and then I'm going to ignite the fumes. So what are those fumes inside going to want to do?
Blow up.
They're going to want to get bigger. The only place they can go is going to be out the back. So the bottle forces the gas out the back. The gas forces the bottle forward, opposite direction. Right? So you got to pay careful attention to this. So we're going to go